Hey, it's MakerDoc here with a quick tutorial on how to make tool trays for all of your medical devices. Now, this isn't the only way to do it, but it's a really simple way. So we're going to make a tray for this laryngoscope handle and Mac 4 blade. So the first thing we need to do right here is get the special measuring device that we scan it with, which is a piece of paper. Depending where you are on the planet, you can use US letter or A4 paper. And the reason we use that is twofold. One, white background makes shadows stand out really nicely. And two, lets us have a exact size background that the tool can use to trace. So after we've taken a photo, I'd suggest you get it as perfectly up and down as possible. You can be a little skewed as you see here. You're going to go to tooltrace.ai, and it's going to take your photo, it's going to trace it, and then on the left here, you're going to select your options, so millimeters or inches, and how much of a outline you want, like an offset. And this matters if you're printing it in hard plastic or something like TPU foam. And then how deep you want this. Obviously for things like hemostats, you only want this a few millimeters deep. You don't want your hemostat down in a hole. A laryngoscope's a pretty thick object, so I left it at the default of 20 millimeters. Now you're going to see your design that it's traced out for you, and you probably want to add some finger holes, which luckily there's a built-in tool to do. And you can see what happens when you do that. I'm going to add one for both the handle and the blade. When you're all set for how you like it, you can view the design in 3D and you can get a good sense of what it is. But we're not done yet because that's just a foam insert. Or it doesn't have to be foam, but essentially that's what it's making. So now we're going to make a case using this. So let's hop over to CAD, and we're going to export it in what's called step format, which is the sort of universal CAD interchange, and pretty much any serious CAD program knows how to use this.
A few moments later.
Okay, so here we have the model we just generated in CAD. And there are a few mods I want to quickly make. You'll notice it's actually two parts, and that's because we selected foam, which is called Kaizen foam, which is a two color foam. And the idea is that your tools obviously show in color. And you can print this way, right? So if you wanted to print the bottom in red PLA and the top in blue PLA, that works fine. The colors here are just the default colors in Onshape CAD, which the first object is blue, the second one is gray. You can set them to whatever you want. Anyway, so the first thing I always do, so a hard edge like this, even if we're making this in foam, has a tendency to tear. And if we were doing this in metal, for instance, that would have a high risk of chipping and obviously cutting things. So generally you want to put some sort of smooth edge, and you can do either fillet, which is a rounded edge, or chamfer, which is a 45 degree. We're just going to do chamfer because it's quick. So let's, you can individually click on all of these outlines, or you can cheat and say, you know what, I'm just going to do the whole box. So if I do that and we say chamfer, we'll do a 1 millimeter chamfer. Fine. Now the edge is broken. Now you notice it did actually do the edge, but whatever. You can remove that later if you really desire. Anyway, you'll notice that's got a nice little broken edge so that when we print this, it won't be sharp, and the tools will slide in and out easier. So we can see that we have a rectangular box, we have sharp edges, and this is what I was talking about. If we print this, you're not going to want to touch that in the OR. Those corners would be absolutely sharp, even with this little chamfer on the edge. So if you were just going to print this as is, I would suggest you chamfer or fillet those edges just to make them less dangerous. But I want to make a case around this. So the cool thing is, right, one of the things you quickly learn in CAD is, unlike what your mother told you, you need to draw on the walls. So we're going to draw on this surface, and we're going to make a sketch, and we're just going to make a box. And so we're going to put a thing around this. And one of the other things that takes a while to get used to in CAD is, in life, constraints generally feel, well, constraining. But in CAD, they're your biggest friend. And so what we want to do is we want to basically outline this box. Now, there are a million ways to do stuff in CAD. I could have actually told it to outline, but for simplicity's sake, let's just put a measurement constraint and say, you know what? That always has to be 5 millimeters from that. And this has to be 5 millimeters from that. And this is Onshape CAD, but pretty much any CAD. So if you use Fusion or Rhino or anything SolidWorks, they all work the same basic way. I mean, they all have different buttons. They might call something slightly different, but they all pretty much work the same way. Okay, so now we have this outline that we're going to extrude to make our case outside. Now we actually need to extrude in two directions because we want a bottom below this insert that, let's say, we will print in foam. And then the outside, we're going to make the walls. So there are, again, like everything in CAD, there's like 27 ways to do this, but I'm going to do this the simplest way so you all can see how to do this. So let's take that, and we're only going to make this we'll do a 5 millimeter bottom, which is excessive, but you know what? Let's make it 2.5 millimeters down, and we'll say this is a new object. And I'll explain why we want a new object in the meantime. So you'll notice that's the entire base. And then we want to extrude again. We need our thing back. And we want to go the other way. We want to add this to the bottom. And we need to actually make it more than 25. So again, you could do it and you could say, well, you know what? I'd like this always to be 5 millimeters taller than this thing. But we're just going to say, you know what? We're going to make it 28. Right? All right. So it's a little taller than the top. You know what? Let's make it 30. Okay. So now we have a lip. And the other thing we want to do, and again, we could have done this before extruding the case. We could have said, hey, make the edges round. So instead of extruding a square rectangle or a 90-degree rectangle, we could have made the edges round. For reasons that I have never been able to find out, the preferred way in CAD is to always do it on the 3D model. There's some performance problem, and this is true in Onshape, in SolidWorks, in Fusion. I don't know why, but all of them, if you use a sketch fillet on many edges, I mean, in this case, it would have been 4. It's not a lot of extruding. That can actually cause problems in CAD. I don't understand it. It, to me, seems like the same thing, but whatever. So now you can see we have a tray with a foam insert. Now we can put a lid on this, and in fact, maybe we will. But let's just start with this object, right? So this is 3 parts. We have these 2, and I'm going to leave these as 2 separate objects so we can, in fact, print it in different colors if we want. You could, in fact, take out the bottom part and just print this directly as a foam insert in the case. That would not be wrong. Now you'll notice this is floating in air because even though we've made this object invisible, it's still there. But I kind of like the idea of having that as 2 colors. That's kind of cool. Now I only have 1 color of printable foam. It only comes in black, but we could do something. So one of the things you learn when you're doing this stuff a lot is name your objects. In fact, I will put a plug in right now. Name all your operations. Again, this is such a simplistic part that you don't really need to. But, when this is on the printer, it's going to be a lot easier to remember. This is the tray. This is the top. This is the bottom foam. And we could, for simplicity, take these two foam objects and not leave them separate. The printer doesn't care. If we tell the printer to print this on top of that and don't switch materials, it'll print it as a single object. But let's start with the tray first. So if we export this, and generally, if I'm printing, I use 3MF. Just remember the STL format dates from 1984. It doesn't even include units. So by default, everybody prints in millimeters, but in fact, it is an unscaled kind of terrible format. I mean, in 1984, it was pretty amazing. I first used it in 1992, but we've come a long way. 3MF is really the modern printing format. Now, in fact, Prusa Slicer, which I'm going to print this on a Prusa printer, can print in step file format also, which is the CAD format directly, but let's just be simple and do a 3MF file. Okay, so if we switch over to Prusa Slicer here, and you can see that. Let me just make the window a little smaller so it fits on screen. There we go. And yes, thank you for the tool tip of the day. We're going to add from my downloads folder. There we go. Okay. And there it is. Not the most exciting part in the world. We'll just print this in PLA. There's no reason to get super fancy. In fact, just for my memory, that is a blue PLA, Airbus blue, because I'm printing a part from my flight simulator. But there we go. So it's gonna take 5 hours to print that at whatever I'm set to. I should probably do some settings, but I'm not gonna bother to go into great detail about how to do 3D printing. What do we got? Oh, layer height. Yeah, that's fine. And this is a 5 tool printer, so you'll notice I have 5 different materials in the printer. Obviously that is not what everybody has, but we're only printing this in one color, so none of the multicolor stuff's really working. I will set this to print in 1. There we go. So that will now print in PLA off my first extruder, and we'll see it after it's done.
1 hour later.
For the insert, we're going to use Soraya Tech's variable density TPU foam. In this case, we're going to use PIBA 95A. What's neat is depending what temperature we print this at and what infill percentage we use, we can pretty much set the density and the squishiness of the foam. And in this case, we'll print it at 270 degrees C. Otherwise, it prints pretty much like any other TPU, except that when it comes out through the nozzle, the additives produce gas bubbles, so it turns into foam. This specific one, PIBA, has nylon in it to be more bouncy. You can decide if you want it more or less bouncy by choosing one of the other foaming agents. All right, printing is done, so let's take a look at what we did. So here we have our case. The walls are probably overly thick at 5 millimeters, but durability is never a bad thing. We put the rounded corners on the outside, and there we go. I did end up making a lid because you can. So it's basically all I did was I took this profile here, extruded that plus the inside, so that made the actual lid part, and then just took the inside and extruded it a couple millimeters more, put a little chamfer on it so it slides in nice, and then just for that little added pizzazz, I UV printed using the photo we took in tooltrace on the lid, and then just put some AI styled text on top. So you can see that now for the insert, which is the really exciting part. We printed that in the Soraya Tech foam. So you can see this is foam. And this is 3D printed. So this is a TPU that starts out as a normal looking filament. And when it gets hot, it has something in it. I think it originally was baking soda. They now use some other chemical that poofs up into gas bubbles, turning this into foam when you print. And you can see, right, our parts fit, right? And there we go. We can easily pull them out. And yeah, it's got a little extra space. We probably should have set this to a tighter tolerance in tooltrace, but I mean, you know, we're not using this while skydiving. It's sitting on a counter. So there you go. Project complete.